In this lesson, I will explain to you naive-based variants, and in naive-based variants, we will discuss multinomial distributions. There are three different distributions which comes under the category of naive-based distribution. So Bernoulli distribution we had discussed in our last lesson. In this lesson, we will focus on multinomial distribution. So here I have written the formula for you, but please do not be confused by seeing this formula. It is the easiest formula and I will try my best to make it as simple as possible. But first of all, I will explain to you what is the meaning of multinomial distribution or multinomial distribution and where we use. So here I have written the definition that multinomial naive Bayes algorithm is a probabilistic learning method that is mostly used in natural language processing. So this is just the definition. If I will ask you what is the frequency of word is in this definition, or how many times the word is comes in this definition, if you have these kinds of problem, if you want to find out the count or if you want to find out the frequency of the specific thing, then you have to use the multinomial distribution. Here I will give you example, then we will go to this formula, how you have to apply. The actual thing is that you should know the concept of multinomial distribution and you should know what values you have to put in this formula in order to find out the probability, right? So I can divide, but here again I would say that please keep in mind that probability range lies between 0 to 1. If you know this very well, never ever you will get your answer wrong. So here are the ages, so I can write down some of my data, then make it this 20, 21, 22 and 23, and here are the probability. Suppose I have 20 students in my class. I'm giving you the example, right? 20 students. I say these are the ages and probability that there are 0.30 probability that the age of my students are 20 years. 0.20 probability is that age of my students are 21 years. And similarly 25 here and 25 here, if you will count this, it should be equal to 1 and this is 1, right? Okay, so this is called the possible outcomes, or you can say this is the population or the possible outcomes. We have 20 students. If I will say that randomly I will pick any 5 students out of these 20 students, what is the probability that I will pick one student whose age will be 20 years? I will pick two students whose age will be 21. You can write, make it like this. Or one student I will pick whose age will be 22. Similarly, I will pick one student and the age will be 23. This is my question. Out of these 20 students, I will randomly pick 5 students. What is the probability that my 5 students ages will be like this? One student 20, two student 21 and so on. So here see, this is the count. Count is available. If you have these kind of questions, then you have to use the multinomial distribution. Discrete count, right? So here see, I can write down P. First I will discuss this, what is the meaning of this, and then we will come to our formula. So here is x1, x2. In this case, our x1 is 1, our x2 is 2, our x3 is 1, and our x4 is again 1. What is this? 1, 2, 1, 1. These 1, 2, 1, 1. My first x1 is that I will pick one student. Then maybe I will pick two students whose age will be 21 and so on. Now, how to put this amounts in the formula? This is most important thing. So I said that randomly I will pick 5 students. It means 5 will consider as the 5 factorial. If you will pick, suppose, or if you will select 6 students, 7 students, then you have to write down 7 factorial. And then in the denominator x1 x1 factorial, x2 factorial, and so on. Now what is x1 and x2? These are count function because we are using the multinomial distribution. So it will be 1 factorial because our x1 is 1, and then 2 factorial, and then again 1 factorial, and again 1 factorial. Whatever count is given here, you have to use as the factorial in the denominator. Now come to this part. As we have 1, 2, 3, 4, 4 different observations, right? So what is the probability? P means probability of 1, probability of 2, probability, and probability of k if we have k numbers here. Similarly, x1, x2 up to k. So here we have 4. That is why we have used 4 here. Here we have probability 0.30 raised to power x1. And what is x1 again? See, x1, x2, these numbers. My probability of, sorry, exponent is 1. And then for P2, my probability is 0.20 probability that I will pick 2 students. So 2 is the power. My probability is that I 0.25, I will pick the student whose age is this, and this is 1. Again, this is 1, 0.25 and 1. Now, what is the meaning of 5 factorial? How you will write down in math? Very simple. 5 into 4 into 3 into 2 into 1. And here is 1 factorial. 1 factorial means 1. If you want, you can write down, otherwise no need. 2 factorial means 2 into 1, again 1 1. If you want, I can write down for you, otherwise there is no need, right? And then multiply, this will remains the same because the power is 1. Here the power is 2. 0.20 multiply by 0.20, which is equal to 0.04, and 0.25 will remains the same because power is 1. Multiply all this, 5 4 times 20, 23 times 60, multiply by all this, you will get 0.045. So this is the probability that if I will pick, or if I will select 5 random students out of 20, the probability is 0.045 that I will pick one student whose age is 20, two student age is 21, 1 and 1 respectively 22 and 23 years of old. So I hope the multinomial distribution is clear to you. Please practice it, subscribe to my channel, and thanks for watching.